Now synth hyphen top dff underscore const 2. Okay, we have already mapped the dff libraries, so no need to map it again because we didn't kill the UC shell. Okay, so let me show you this report that came when we synthesized the previous design. So in the previous design, when we synthesized, I'm just scrolling back. If you see, this is important. See, in the previous design, this while we are synthesizing dff underscore const 1, if you see here, when it is printing the statistics, it is inferred a dff. It has inferred a dff for dff underscore const 1. This is very important for us to note and understand what is printed in the statistics. It's very important. So it is inferring a flop here. Okay, whereas now when I go back to our present design, it has not inferred any flop. If you see, it has just inferred wires. It has inferred 0 cells, 0 memories, nothing. It has not inferred anything. Okay, let us link our design abc-liberty dot slash mylib lib. So now I'm going to do show. Boom, there is no flop. Irrespective of my clock, reset, anything, my Q was always 1. So there is no need for any flop. So it just removed everything and just connected. Clock is having no load, reset is having no connection, clock is having no connection. Just it's a 1 tick B1 and connected to Q. That's it. Nothing else. So this is what is the sequential optimization we were talking about. Okay. So now let's look at few more examples. Now, okay. So let's look at dff underscore const 3. What's given there? Const 3. So const 4 and const 5, you guys will be working it as a lab. So const 3, let's look at this. This is something very interesting piece of code. Let's look at this. What's going to happen here? dff const 3. So here I have a 2 flops clearly. So now what is happening? Upon reset Q, there are 2 flops. So both are getting the same clock and same reset. But Q is becoming 1 tick B1 upon reset. Q1 is becoming 1 tick B0. That means this is like a set flop. This is like a reset flop, correct? Because Q1 is becoming 1 tick B0 upon this pulse, and Q is becoming 1 tick B1. And else part is the one which is defining the D logic. So else Q1 gets 1 tick B1. That means this D pin is connected to 1 tick B1, and Q gets Q1. That means this output is connected here. Now think and tell me whether these flops will be optimized or it will not be optimized. Let's think about it. So let's draw the clocks and see what is going to happen. Let's say this circuit, when we synthesize, we expect 1 flop, 2 flops, no flops. Let's try to understand this. So let's say my reset is going to be applied something like this. This is my clock. This is my reset. Let's look at how Q1 will look, how Q0 will Q will look. So Q1 is a reset flop. That means whenever reset is getting applied, Q1 is going to go 0. And after reset is deasserted, it's going to wait for the next rising edge of the clock to become 1. It's going to be permanently 1 after. So clearly Q1 cannot be optimized. Let's look at what is going to be Q2. Q or Q. Q is a set flop. So upon reset, it's going to go to logic state of 1 because reset is applied, and reset is like acting like a set because Q is going to 1 upon reset, correct? So it's like a set. And on this edge of the clock, what will happen? Will Q remain to be 0 or 1? Kindly, this portion we need to understand thoroughly. Let us zoom in on this portion. So if I zoom in on that clock there, what will happen? This is my clock. Now this clock edge is simultaneously seen by flop. Let me call this as A, let me call this as B. The flop A and flop B, this edge is same. Okay. Now when the clock edge occurs, Q1 will go 0 to 1 after the TCQ delay, correct? Q1 will go from 0 to 1. This is my Q1. This delay is my clock to Q delay, correct? So what value will be sampled by the flop B? What value will be sampled by flop B? Tell me. What value will be sampled by flop B? In this edge, the flop B will sample the value of 0. So in this edge, the flop B will sample a value of 0. And on this edge, the flop B will sample a value of 1. So this is the output. So the output Q will be always high except for 1 clock cycle duration. So can I remove of Q? Can I remove a flop B? No. Can I remove a flop A? No. So this circuit, though it is connected to constant here, and it's having looks like it's connected to set and reset alone, but still both the flops will be present in the circuit. It's a very beautiful circuit. Let's validate our understanding by simulation and then by synthesis as well.